Okay, seriously, this is the last video for this lab. The whole point of this was to figure out how much carbon is actually stored in a single tree. So now we're going to be calculating that carbon storage. First, you have to calculate what's called the green weight, which is an estimate of the mass of the tree when it's living. So it has all of that water in it. And this estimate includes all of the wood content and any moisture in the tree, because the moisture in the tree can be up to hundreds of liters. The green weight can be quite large. So as you can imagine, weighing a live tree and keeping it alive is not feasible. So we foresters use a set of formulas to estimate green weight. Those formulas are based on measurements from many different tree species, kind of averaged out. So calculating green weight, if you want to be super specific, you might be able to find the calculation for the tree species that you're actually working with. Anyhow, so the percentage of moisture in a tree varies by tree species. Yeah, just talked about that. So the equations used here are an average for trees in the southeast. So they're not going to be probably as accurate for us here in the Pacific Northwest. Now, I was able to find a spreadsheet that had a bunch of tree species on it and their green weight calculations, right? So we're using this measurement 0.0577, and that's for trees that have a diameter smaller than 28 centimeters. And for trees that have a larger one, we're using 0.0346. So this changes based on tree species. And I did find one for Douglas firs, but I'm not going to get that complicated. You totally can if you want. Okay, so we're going to use our calculations for diameter in centimeters. So if you translated that to meters, make sure it's in centimeters. And the calculation we just got for height, which should already be in meters. All right, going back up to the first table that we did, I am using the diameter of my tree, not the circumference, but the diameter, right, which was circumference divided by pi. So my tree was 33 centimeters in diameter, which means I will use this second calculation for trees with a diameter greater than 28 centimeters, because mine was 33. So the green weight of that tree equals 0.0346 times my diameter, which is 33, squared, times its height, which we just calculated is 11.42. Okay, so I'll put that in the chart down there so you can see it. Okay, so my equation looks like 0.0346, because I'm using the second calculation here, times diameter squared, which is 33 times 33, times 11.42. So if I was putting this in a calculator, think about your order of operations, which I had to look up, which is please excuse my dear Aunt Sally, right? So please excuse, parentheses, exponent, and we got an exponent, d squared, so you got to do that first. And then it doesn't matter what order I multiply the rest in. So I got a total of 4,300, and I'm going to round to the nearest whole number, 3. Wow, and that's in kilograms. That's my green weight. That is a heavy tree, 4,300 kilograms. So the second part of this is calculating dry weight, and that is when you take a tree and you take the wood and you dry it in an oven. On average, the weight is about half of what it was before. So we just take our green weight and we multiply it by 0.5, or we divide it by 2. Okay, my dry weight is 2,151 kilograms. And for reference, I am 50 kilograms-ish. And so this tree is roughly 43 quasars heavy when it's dried out in an oven after all of the moisture has been removed. Okay, the moment you've all been waiting for, estimating carbon content in kilograms. And so on average, scientists have found that about 50% of a tree's dry weight, so half of its dry weight, is carbon content. The other molecules are things like hydrogen, oxygen, nitrogen, but about 50% of it is just carbon. So we're just going to do the same calculation. So divide or multiply by 0.5. Okay, so you take a single atom, carbon, and you You measure a tree just based on how much carbon it has. Our tree, my tulip poplar, has 1,075 kilograms of carbon atoms, which I think is really cool. And so I want you to think about, like, where did that carbon come from originally? Like, where is the tree getting all of that carbon to make its to make all of that wood?